So marking the quiz. Oh, it helps if I plug the actual speaker in, Mr. Dueck. Let's do that. There we go. Oh, my good old favorite student. Good old Ann. What's acceleration? I'm going to give you one definition. If you have something else at the end of the quiz, I'll just say, anybody else have any other answers, and you can call them out, and I'll quickly say yes, yes, no, 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 no. For now, if I was giving I guess 2 marks. So first of all, is acceleration a vector? Yes, that gets you 1 mark. What's acceleration? Change in velocity. Oh, wait a minute. I got a nice short way to write a change in. I have a symbol for that, do I not? Little delta. Change in velocity. In fact, if you wanted to, you could really write change in velocity with respect to time. But my fallback is if your velocity is changing, you're accelerating. Now, that means there's 2 possibilities, because velocity is a vector, and all vectors have both what and what. Remember from last day quiz. So there's 2 ways to accelerate. I can change the acceleration magnitude. That's what happens when you're going in a straight line and you hit the brakes in your car, or you press the gas in your car. I can also change the direction. When you go around a corner at a constant speed, your speed's not changing, but you are accelerating because you're changing your direction. Hadn't thought of that, but that's what cornering does. Okay. So 1 mark for each of those. An accelerating must at all times changing velocity. It can have a positive velocity. It can also have a negative velocity. It can have an increasing speed, but you can also be decelerating, decreasing your speed. It can have a changing direction, although not necessarily have a changing velocity. That covers everything because velocity is both magnitude and direction. Number 3, I will take more than 1 answer if you present me with a good, convincing argument, because some of these, Olivia, are worded deliberately vaguely to get you thinking, mean person that I am. So increasing or you know what? Velocity is positive, acceleration is positive. I would argue that's probably, you know what? I'm going to use, how about I for increasing and D for decreasing. You can write increasing, decreasing. Velocity is positive and acceleration is negative. What do you think? So velocity is positive. Going forwards, acceleration is negative. Back, oh, you know what? Hitting the brakes in your car is that example. So I would argue decreasing. Velocity is negative and acceleration is positive. Velocity is negative backwards, acceleration is positive forwards. I guess that's when you're in reverse and you hit the brakes. What would you say there? I would accept decreasing. Can someone give me an example how that could be increasing? Because that one, there is a way you can describe that as increasing, and I'll take it if you give me a good argument. Yeah?
If you're traveling backwards but you're speeding up, so your acceleration is positive.
So I will accept that argument as well. What she said is actually, Mr. Dueck, even though you're slowing down when you hit the brakes in reverse, as numbers go, your numbers are getting closer to 0 and then positive from negative. And I guess as numbers go, if you start in the negatives, well, what's bigger, negative 10 or negative 8? Technically, negative 8's bigger, right? Technically. So it's going to depend on whether I mean, and this is why I don't like using the word increasing or decreasing to describe what's going on in real life. I'll say, hey, decelerating, accelerating, what's going on here? So yeah, you can make that argument, and I'll give you the mark for that. Okay, so that one I'd take both. Velocity is negative backwards. Acceleration is negative backwards. So that one as well, most people would say, oh, you're speeding up in reverse. You're pressing on the gas in reverse. You're increasing your velocity. And I would live with that. Although I would also accept, because the numbers are getting more negative, you could say negative 30 is actually a smaller number than negative 20, which it is. And you could make the argument that it's decreasing. If you said that, I would accept that answer as well. Okay. And I'm deliberately vague to bring up that discussion in case any of you were like working on the quiz ahead of time in class, but with your teacher and hounding your teacher to try and explain some of these questions and wondering why it was so confusing. I don't want to mention any names. Hey, what does the slope of velocity versus time graph represent? Acceleration. Car's velocity increases from 5 to 25 in 5 seconds. Okay. By the way, the reason I didn't just say what's its acceleration, Brandon, I'm being fussy. Have you been in a car? Do you drive? Okay. Who drives? A couple for you? Okay. When you press the gas and just hold the gas down in the same place for a few seconds, is your acceleration constant or does it actually change? I think most cars, when you press the gas, they accelerate faster at the beginning. And then as your engine gear, as the gears change, you don't feel it as much anymore. So technically in a car, acceleration isn't constant, but because cars are such good examples of everything else, we'll pretend that it is constant. And that's why, Olivia, I included the word average acceleration, because I was being, technically that's what you're finding. But let's just pretend that's not happening. We're finding the acceleration. Right? A equals VF 25 minus VI 5 all over 5. Hey, I think I can do that in my head. 25 take away 5 is 20 divided by 5. 4? How many sig figs in my answer, technically? I think you could make an argument for 2. I'm not going to be fussy on sig figs. If you got an answer of 4 and you had the units of meters per second squared, that gives you 2 marks. If you forgot the units, Jordan, I always take a half mark off for forgetting units. I smack you gently. Otherwise, I would probably go something like this. A half mark if I saw that, 1 mark if I saw that, and a half mark for the answer. I'm much less concerned with the answer. I'm much more concerned with the method. Is that a hand up? No? Yeah? Okay, hang on, we're going to do that again, but this time you're... Yeah, there we go. Just a little daylight between the elbow and the desk. Sorry? What if you got the squared? Half mark off. Let it sting, because that way you won't do it on the test. In fact, I'm almost tempted to say like 0 just to really pee you off, because then you'll be mad and you'll remember on the test the entire time to go check your units. I won't. But sometimes a little pain helps us remember. Turn the page. A bus is moving at blah, 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 blah. Oh, and again, they want me to find average acceleration. I guess VI is 30. VF stops is going to be one of our physics words. At rest is going to be one of our, so we're learning some physics words also give us velocities. T equals 6. In fact, I think it's going to be A equals VF minus VI all over T again. It's going to be 0 minus 30 all over 6, negative 5.0 meters per second squared. The negative scared me for a second. No, we're slowing down. Actually, I should have expected a negative, yes? 1 mark, half mark, half mark. No units or forgot the squared. Again, half mark off. Smack yourself on the hand, get angry, and you won't forget it when it counts. By the way, if you haven't figured out, by the end of the year, you'll have, because I put quizzes in the same bin as homework when I do your grades, by the end of the year, losing a mark on a quiz, I think I worked it out one year, it was like 0.0001% of your grade. It didn't affect your grade at all. But losing them on the test would. So we'll sting you on the quizzes, so you don't sting on the tests. I think here they want me to find V final. So let's see. V final equals V initial plus AT. Did they give me V initial? Yep, 3. Did they give me A? Yep, 5. Did they give me T? Yep, 3.5. So it's going to be 3 plus 5 times 3.5. Can I do this in my head? Well, 5 times 3 will be 15. 5 times 0.5 will be 2.5. So it's 17.5 plus 3. Is it 20.5? Meters per second. I guess technically if I went sig figs, it's 21 meters per second. So whichever of those you put, I would take. But I don't like rounding off that much. That's a big round off. Oh, again, 2 marks if you got it right. Otherwise, 1 mark, half mark, half mark. And again, units are a half mark. Number 8, how long? Hey, that sounds like time to me. How can I rewrite this equation and get the t by itself? Remember how tough this was a couple of weeks ago? And now you're like, oh, his eyes are almost rolling at me. Dueck, t equals vf minus vi over a. Oh. And again, if you haven't got there yet, trust me, you will. You will. And it's a great skill. So Brad, you said t equals vf minus vi over a. In fact, I'd give you 1 whole mark if I saw that. I'm going to try doing this without even deficking. Let's see if I probably on a quiz would always defic, but in my homework, I might start saying, am I good enough to take some shortcuts? If I am, that's actually a good thing in my mind. I think I might say V final is 10, V initial is 2, and acceleration is 3.5. 10 take away 2 is 8 divided by 3.5. Let's see you do that one in your head, Mr. Dueck. Okay, yeah, that one's yucky. It's got a 7 in it. 3.5 has got a 7 hidden in there. 7's a yucky one. This is going to be like a long repeating decimal, yes? Yeah. It's 2.2857142857142857142857142857. It repeats. Trust me. I'll go 2.3 seconds. What must your initial velocity be if you accelerate? Oh, now they want me to find VI. Okay. I don't know how often we've done this. How would I get the VI by itself here? Actually, that's so easy that it might be tough. How would I get the VI by itself? Divided by? Why subtract? Because and that's the most common mistake. I'm glad Carly did it, actually. Carly said, isn't it VF divided by AT? Actually, if we're trying to get the VI by itself, what's the AT doing? It's adding. That's why I said it's so easy that it's tough, because kids get so into the dividing thing. Yeah, sometimes it's just subtracting or plussing it over. In this case, subtracting it over. I think VI is going to be VF minus AT is going to be, I'll try and without deficking again, 20 minus 3.2 times 3.3. It's going to be 20 minus 3.2 times 3.3. 9.44? No? Yes? Yeah. 9.4, I guess technically the 2 sig figs, meters per second. And again, I would go 1 mark if I saw that, half mark for the numbers, half mark for the answer. But if you got the right answer, you get 2 out of 2. Can you please give yourself a score out of 17? And any lawyering with me, any other ones you're wondering if you gave the right definition, now is your chance to ask. So continuing from last day, we're looking at throwing a ball vertically downwards. And we had found V final impact. We did say, Noah, the only problem with using the VF squared equals VI squared plus 288, by the way, hopefully you have your yellow formula sheet out by now, or you've got them memorized. The only problem with using this one is it's going to give you sometimes a scalar answer, specifically when you're taking the square root. And so you'll have to interpret, you'll have to say, I think I'm going down, and add the vector, the negative yourself. And in fact, Jacob, some teachers I've seen actually don't teach this equation. It's kind of redundant. You see, the other thing we could have done is we could have used this to find time, or we could have used, we had other options. But, yeah. And then we did the time for the ball to hit the bottom. Come on. Try this again. There we go. Time for the ball to hit the bottom. We said we can't use d equals VIT plus a half AT squared because unfortunately the VIT doesn't cancel, and that gave us with a t and a t squared. And I said you're going to learn something called the quadratic formula this year, and then you'll be able to deal with it, but until then, we're stuck with what we got. So we had to use V final. We had to use an answer from part A. Okay, we're at that stage now. And then the last thing where we left off was C. C said if the speed of sound is 330 meters per second, how long will it take for the sound of the impact on the ground to make it back to the top of the cliff? If we start timing from when the ball is thrown, I think what we're going to do is we're going to figure out how long it takes the sound to get back to us, and then add the free fall time, because it said we started our stopwatch when we dropped it. Does that make sense? Okay, so pause here. I can erase this. We are finding a time but we're going to kind of do this in two parts. This is going to be over here. Total time. What I want to find first is how long it takes the sound to get from the bottom to the top. What do I know about sound? Well, they told me that the speed of sound is 330. Sound is a little strange in that it doesn't have an acceleration. There is no v. In fact, you know what? It's just that. That's why you'll notice normally when I've said what's the velocity, or when someone said it's a velocity, I've said which one, initial or final. You'll notice, Taylor, this time I didn't put an initial or final next to that 330. I just wrote v. V. How far does it have to travel? 120 meters? See, I think what I can actually use is this. But this time, Mark, strangely, I can get rid of that whole mess because A is 0. Yeah. Sound doesn't accelerate. Sound hits full speed right away. Okay. If you want a better reason, it's because waves, when they propagate through a stub. Anyways, trust me. Right. Sound doesn't slow down or speed up. Oh, I just lied. Okay. In this particular situation, sound will hit full speed right away and will be a constant speed. Is that okay? I have to pick my words carefully because there's something called Doppler shift where sound does change. I guess and Jake, even though I wrote VI, since there's no acceleration, I really don't need to put that I there. It's VI is V final, is V average, it's V. How long will it take for the sound to get back to us? It's going to be 120 divided by 330. How many of you have ever seen a situation where you could see that sound was delayed, so you saw something in a distance, and then it took, oh, fireworks, there's a great example, right? You see the explosions and there's a slight delay. Yeah, that totally works. Lightning and thunder. In fact, hey, earlier this year in September when we had that freak storm, we had a lightning strike where I'm pretty sure it hit the light posts here. So there was almost no delay. I don't know about you guys, but so whenever you see lightning, start counting. 1, 2, 3. Every 3 seconds is about 1 kilometer away. If you're wondering how far away the lightning struck, every 5 seconds is about 1 mile away. So every 3 seconds is about 1 kilometer. None of you do that? Oh, I do that every time. I always count.
I thought it was like the flash.
Pardon me? You see the flash, then you 1, 2, count until you hear the thunder, and that tells you approximately how far away the lightning hit from where you are. And if it's right away, get indoors. Or stay in a car. 0.36363, is that right?
Yep.
So I'm going to go 0.36 seconds. So the total time how long did it take the object to fall down?
2.7 seconds.
And you probably, because 0.36 seconds, Jake, that's enough for our eyes to spot. You would probably see the puff of dust and notice that there was a delay before you heard it. Not much, because 0.3 seconds is about, maybe a little longer, probably about like that. But that's enough for your brain to register and pick up. Do you get 3.06 seconds? A couple more, we're done. I heard a phone. Where'd that phone come from? Chris? Chris is trying hard to keep a straight face. Chris. Chris. Thank you, sir. So, donuts, Timbits, Timbits. Could have just put your phone on vibrate, my friend. So let's make sure we get our Timbits from him. No, not beat him up in the hallway. I'd rather have the Timbits. Number 4. A ball thrown vertically upward returns to its starting point in 5.6 seconds. Find its initial velocity. Okay. What do they want me to find here? Are we throwing something? Yeah? Oh, then you know what? A equals what? Negative 9.8. They don't need to tell me that. Pardon me? V final is not 0. V final is never 0. I will never, ever, 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 ever say that after it hits the ground it's 0. We've said that V final is always the impact velocity. Remember me going on a rant about that? Don't do that. Yes, any free fall object technically after it hits the ground is 0. Why would I bother even assessing? Nah. V final is not 0. Ah, but I do know V final. I know it algebraically. I know it as an expression. Are we starting on the ground in this question? I think so. Are we ending on the ground in this question? I think what goes up must come. You know what V final is? It is. It's negative V initial. Now, how does that help me? Well, I do have an equation that has VI, AT, and VF in it. This one. Only this time, I'm going to tweak it, because what's V final? Really, it looks like this. Right? What are we trying to find? Well, let's get the VIs to the same side. I think I'm going to go from both sides. That's going to give me the AT drops down like a domino. That's negative VI take away VI. Hey, wait a minute. Aren't those like terms? That's like negative X minus X, which I don't think cancels. I think negative X minus another X, or negative VI minus another VI. Hey, what's that simplify to algebraically? What's negative 1x take away one more x? Negative 2x. What's negative x take away x? Negative 2x. What's negative vi take away vi? Follow it. This is Math 9 in disguise. Negative 2 vi's. Not squared. Not multiplying. Brad, what are we trying to find? Hey, not so easy now. I know, this is a tougher one. So what are we trying to find? Yeah. Hey, now I can get the VI by itself. How? What's on the same side as that there VI? You know what? There's a negative 2 timesing, so I think I'll divide by negative 2. I think we'll get this. VI is going to be AT divided by negative 2. It's going to be negative 9.8 times 5.6. Now, if this is scaring you, I'll show you another way to do this in a second, which is why I've kind of left some room over here. In fact, I'm going to end up doing that in a second. Negative 9.8 times 5.6 divided by negative 2. Okay, Apple, you can wait. 27.44? Positive? Oh yeah, that, I was hoping for a positive because we are throwing it up. Yes? 27.4 meters per second. How many sig figs? Okay, technically 2, whatever. There's another way I could do this. Are we starting on the ground, Noah? Yeah. Are we ending up on the ground? So we're going up for exactly the same amount of time as we're going down. So here's what you could do. You could divide t by 2. What is 5.6 divided by 2? Sorry? 2.8? Yep. If I'm only looking at half the time, how far have we traveled? Where are we after 2.8 seconds? If it took 5.6 seconds to go there and back, where am I after 2.6 seconds? 2.8 seconds. At the top. Why is that so nice? Because I do know V final at the top for a split second. What's V final at the top for a split second, Alex, my friend? Absolutely. See, now you could say V initial, don't know, A, negative 9.8. You can make a little note here. The reason we divided it by 2 is because we want to get to the top. And I do have an equation that has VI by itself. VI equals VF Carly minus AT, yes? And if you go 0 minus 9.8 times, minus negative 9.8, well, let's type in the numbers. 0 minus negative 9.8 times 2.8, I bet you also get 27.4. Let's double check. 0 minus negative 9.8 times 2.8, 27.44. I'd give you full marks for either of those. This is nerdier because you get to do some clever algebra. This is, I think, the divide the time by 2 method is easier. That's one, Brandon, worth putting in your back pocket. If you're starting on the ground and ending up on the ground, if there's no cliff. If you know total time, you automatically know time to the top. It's half of it. Or if you know time to the top, you automatically know total time. It's double it. Handy. Last one. A ball is thrown vertically upwards at 35 meters per second. Check. Calculate the velocity of the ball after 4.2 seconds. Okay. Calculate what? Which one?
Final.
I think V final. What's that 35? The initial? What's that 4.2? Oh, time. It's not enough. Must be something else I know. Oh, yeah. So if it's a car question on the ground, like on the quiz, I gave you the accelerations. But as soon as we're talking free fall, you can you can fill this in right away. unless it says you're on a different planet, in which case it'll be really clear you're on a different planet, and it'll give you the acceleration on that planet. Moon is about 1.6, negative 1.6. Those are the only two interesting ones. Oh, and we got the V final by itself already. Same equation that we flogged to death on your quiz. 35 plus negative 9.8 times 4.2 negative 6.16. Hey, what's that telling you? Is it on the way up or on the way down? So I can tell you, how many seconds already is it on the way down? 4.2. So it took less than 4.2 seconds to get to the top. Okay, which means it's going to hit the ground in less than 8.4 seconds if I double that time. Okay. Jacob, what's B want me to find? Height's not a physics word. In terms of our stuff, height means what? Displacement or distance. Yep. So B, D equals question mark. Is it still 4.2 seconds, Jacob? In part B? Yeah, then I'm not going to read dfic. I read dfic anytime the time changes. Then I relist everything. But here, I've got it all right up above me. I've got it on the same page. So I'm looking for an equation. It's got to have a D in it. And then VITA. It can have a VF, but if I can avoid using it, Jacob, I'll try to. Is there an equation that has a D, a VI, a T, and an A? Good, solve it. On your own, go. This one's nice because the D's already by itself, I think, yes? So do the plug and chug. I'll freeze the screen. Get your calculators out. You can try this yourself. VI. I'm getting an answer less than 70, more than 60, less than 65, more than 60, less than 62, more than 60. In fact, I think I'm getting that. 60.6, 61 if I go to 2 sig figs meters. Pretty good throw.
Yeah.
Well, are you baseball? Okay. Do you pitch? What position do you play?
Outfield.
Anybody else here play baseball, or is it just? So anybody pitch? Okay. Radar gun. What's the fastest you pitched in miles per hour?
I haven't really got time. But
Roughly.
Around
80?
80.
82? Okay. Because baseball is all done in imperial U.S. unit miles per hour. For what it's worth, if you take meters per second, so see the 35, if you double it, that's roughly miles per hour. So you guys, if you're if you're hitting 80, you're pitching at about 35 meters per second, give or take ish. If you're looking for a rough guess, and I always try and give my physics nerds a bit of a. It's nice to know roughly how big numbers are. So this would be if somehow, in theory, if we ignore air resistance, if you guys were able to throw straight up at full speed, which is awkward unless we came up with some kind of a contraption where you could like lay on your back but also take a bit of a step into, I don't know. But in theory, you could get it up there that high. Oh, and that's already on the way down. If you're bored, you can figure out how high this would actually get, and that would be, in theory, how high you guys could launch it. Who else? You baseball as well? Pitcher or no? Ever radar gun yourself?
Once, and that was a year ago.
And?
It was like 75.
Okay. There was a great... Jamie Moyer. Do you know who Jamie Moyer is? Do you know who Jamie Moyer is?
Yeah.
So Jamie Moyer was a pitcher who pitched until he was 45 or 46. He only retired last year. He was with the Mariners for about 15 years, okay? And he was a slow pitcher. Like, he pitched in the 60s. Control pitcher. So the Mariners, about 10 years ago, they had a great commercial. They had Jamie Moyer pitching, boom, and they had the radar gun. 110. Jamie Moyer pitching again, boom. 115. Jamie Moyer pitching again. 118. And so the back catcher is just shaking his head, and then the manager looks at the camera. Yeah, these no radar guns are from Quebec. They're in kilometers per hour. And then Jamie Moyer pitches again. 120, he looks at the camera. Ooh la la, he says. You know, a little Quebec thing, right? Great commercial. Back to here. Last one, C. How much time before it hits the ground? Oh, I guess time. I better read DFIC because now time has changed. So A was negative 9.8, I know that. What was VI, 35? That's not enough. What else do I know? Alex, what's V final? Don't say 0. Are we starting on the ground? Yeah. Are we ending on the ground? Hey, what goes up must come. What's V final? Negative 35. Okay. By the way, you're going to find if we're dealing with a cliff, this becomes much, much tougher. Because you can't use what goes up must come down. You got to fall back on something else. What's the equation that has T, A, VI, VF, and get the T by itself?
Oh, like that T equals VI minus VF over A.
I think it's VF minus VI over A, is it not? Sure, that's you hear? Yeah, that's what I meant. And whenever I get something wrong, Mr. Dueck, I always meant the right answer. So can you give me 100 on everything? Yeah, right. It's like the guy that loses the race. I wasn't really trying. Okay, sure. $7.14? 7.1. By the way, if you divide that by 2, that's how long it took to get to the top. Right? You could find that also by letting V final be 0 and crunching it, but okay. What's your homework? Bear with me for un momento as I pause.